Okay, welcome to Algebra 2, Unit 2.5. In this unit, we're going back and forth between standard form of the quadratic and intercept form. Now, standard form looks like this, the ax squared plus bx plus c, and intercept actually has parentheses x minus p, x minus q. So, I'm just going to show you real quick. They're really fast to go between them. In standard form, in order to get into parentheses, you have to play that X game. If you have not been in class playing the X game, then you need to pause right now and go to the basic skills, the X game, and watch it. Okay? So, I would take the first times the last, that would be -4. Two numbers that multiply to be -4 would be -4 and +1. They also add or subtract to be -3. Because there's a 1 here, I can convert straight to my answer if I would like to. Otherwise, I can go to those 4 terms. But straight to my answer would look like this: x minus 4 and x plus 1. So I just converted standard form to that form. Now, in intercept form, all you have to do is box or FOIL. X squared plus 2x plus 5x plus 10. X squared plus 7x plus 10. Now, I'm not really instructing you how to box and FOIL or how to do the X game and factoring here. If you don't get that, go to 3-term factoring, X game, go to box or FOIL for that. Okay, intercept form displays zeros. Graphing intercept form, this is what we do. First off, I get it converted. 1 times 12 is 12. 2 factors of 12 that would add to be -8. I know that they have to have like terms because, like signs, because this is a positive. So they've either got to both be positive or negative. I say they both need to be negative because they have to add to be a negative. The 2 numbers that I can think of that multiply to be 12 and add to be 8 would be 6 and 2. Now, because there's a 1 out front, I can just go straight to my answer: x minus 6, x minus 2. Now, in graphing form, this means that I take x minus 6 equal to 0. In order to get x minus 6 to equal 0, x would have to be 6. X minus 2 equals 0. And again, if you didn't know how to do that in your head, just go up the PIMDAs and solve for this x. X would equal 2. So now I know my 2 intercepts: 6 and 2. Now, remembering a parabola is symmetrical, I know that halfway between those is my axis of symmetry. All I need to do is plug in this value. The axis of symmetry is 4. Plug that into the equation, or the other thing I've seen students do is they take the amount that it took to get from there to there, -2, the amount to get from there to there, +2. They multiply those, they get -4, and then they come over and they look for any number in front here that needs to be multiplied by that. There isn't anything, so I know that my vertex is at -4 on this graph. So it goes down to -4. I have 3 points and I can connect them. Now, if you wanted to, you could actually plug in that -4, plug in this +4 right here, and you would end up getting these same 2 numbers and then multiply them and get that. So you can plug it into the equation or get it off the graph. That's how you graph them. Okay. This is a really nice one to go into intercept form, because in standard form it would really be ugly a little bit to try to do a -b/2a to find your axis of symmetry. So instead I look right here and I say, okay, there's a 1 out front. I'm going to go straight for my answer. Don't even need to draw the x game because I know it's going to be x, x. Since that's a negative, it would be a negative and a positive. What 2 numbers multiply to be 5 and subtract before would be 5 and 1. The number farthest from 0 always matches that sign. And we bring the negative 1/3 back. Okay? So we now know our zeros would be 5, 0 and negative 1, 0. Because when you set those equal to 0 and solve, that's what you get. So we have negative 1, 0 and 5, 0. We should be picturing on our mind's eye that it's round like this, doing a maximum because of the negative out here. So if we tick off to the center seems to be 1, 2, 3. 1, 2, 3. So it appears to be at 2. We can plug 2 in here. 2 minus 5 is negative 3. 2 plus 1 is positive 3. Or you can do it right here. It's 3 and negative 3. Multiply those and you get negative 9. Negative 1/3 times negative 9 would be negative and a negative make positive 9/3, which equals 3. So we know that our vertex is up here at 3, and it's graphed like that. Okay? Please make sure and use graph paper. I've got it over there. Just grab some while you're taking notes. Modeling with quadratic intercept form. We have an archway that's 0.5x squared plus 2x. I would have a tendency on this one, since it's got a fraction, not to do standard form. I would have a tendency to factor. And probably get rid of that 1/2. So half x, bring that out to the front. And remember, when you distribute this, you should get that answer. So I know 1/2 x times x would be 1/2 x. And 1/2 times 4 would be 2. And 1/2 x times 4 would be 2x. Okay, so now I could write it this way, 1/2 x plus 0 and x plus 4. So I know my x-intercepts would be at negative 4, 0, and 1/2 x plus 0 equals 0. Divide by 1/2. Divide by 1/2, and I have x equals 0. Okay, so my intercepts are at 0 and at negative 4. Okay, what is the width of the base? Width of the base would be 4 meters, I guess, is the distance there. Now, I would put that on graph paper, and I would actually put in that negative 2 to find the vertex, and then when they ask, will this fit? Actually just go up on the boxes, center it, and go right here and go out a width of 2 meters, and make sure that you're up at a height of 1.75, that's 1 3/4, and come down and see. Because if the corners are outside the arch, then it won't fit. If they're inside the arch, then it will. And that's the easiest way to do that kind of problem. I have a lot of those. You'll see it even on the final. Thank you very much. Have your questions ready.